Hi guys, and welcome back to another episode of Physics Explained. Today we are doing another Physics in 5, and as promised, if you saw the Facebook channel earlier, or even the YouTube channel, I'll put it up on there, we are doing planetary orbits today. Specifically, we are looking at Newton's gravitational constant. Let's go. Okay, so planetary orbits, how exactly do they work? Well, up on the board here I've got a rough diagram of the Sun and the Earth and an elliptical orbit. Now, Newton's first law states that nothing will move unless it's acted on by an external force. That means if there wasn't any external force, the Earth would stay perfectly still at the distance it is from the Sun. But we know that isn't true because we know we get seasons. And so what we have is we must have some inward force here and some velocity here. So we've got a V here and some force here inwards pulling us in towards the Sun, and then combine that with the velocity and we'll get this elliptical orbit here. And obviously if you've read the article already on the website, you'll know there's some acceleration towards the surface of the Sun as it comes down this sort of shallower part of the orbit. Isaac Newton discovered that objects with mass exert a force on each other, and he called this gravity, and he came up with a gravitational constant which makes all the maths work. But what it basically means is if we call the Earth mass 1, the Sun mass 1, and the Earth mass 2, then he said that the force this force here, this force G, that the Sun exerts on the Earth is related to the two by timesing them both together, dividing them by the square of the distance between them, so that's this distance here, it's r, and then he times it by his gravitational constant, which is just a number. It makes all the maths add up, you know, with the two masses and the distance, it makes the force add up, so we know that's right. But if this were true, then the Earth would just plummet towards the Sun, so there must be something else going on here, right? It can't just be that there is an attractive gravitational force. And a lot of people will tell you that this force doesn't exist, and it was actually on Brainiac, if you remember when you were a kid watching Brainiac, and they said this force doesn't exist. I think it was Richard Hammond said, you know, this centrifugal force, it's not real. There must be another force acting outwards, otherwise we'd just plummet towards the Earth and we'd rotate round, but eventually we'd spiral in towards the Sun, right? So there must be, I'll redraw the Earth over here again, there must be a force this way, there must be, because otherwise, I mean, the Earth's orbit stays relatively constant. We don't get 1 year 90 degree centigrade temperatures and then the next year we get 25. It's not what happens. And so we call this force the centrifugal force, and that's equal to the mass of the object, so mass 2 in this case, times the velocity squared, divided by the distance, the radius again, this distance here. And this force, this gravitational force, when we're talking about orbits, is actually also known as the centripetal force, and a lot of people call it FP. And when the two forces are balanced, then we get this orbit, and it's the same thing that keeps satellites up around the Earth's surface. It's the same thing that keeps the Moon orbiting around us, and it's fairly simple to figure out, really. I mean, we can calculate the mass of the Sun from this based on how far away we are from the Sun, which is fairly easy. We know it takes roughly 8 minutes for light to reach the Sun, for light to reach us from the Sun, and we know roughly the mass of the Earth because we can calculate it. So we can figure out the mass of the Sun, and it's actually well documented now. So yeah, there you go, guys. Newton's gravitational constant, this thing, G. Okay guys, so if you enjoyed the video, remember to hit that like button, subscribe to the channel for more, comment if there's anything you want me to do, and you can find me at JM Journalism on Facebook, JM Journalism on YouTube, although if you're watching this you already know where to find me, and at JM_journalism on Twitter, or just search Physics Explained.